In this video, we're going to witness how MECP certified master mechanic Steve Ledford constructs a stacked enclosure. A stacked enclosure is one of the most complex boxes any 12-volt retailer can be asked to make. The reason for building such an enclosure is that layering your wood gives you the freedom to choose a more radical box design. For this enclosure, we have decided to use an alternating wave pattern. By eliminating the freestanding waves normally created by conventional box designs, this design complements the exceptional range and handling of our 10-inch Imagine Series subwoofer by Hybrid Audio. To help you better understand why this is important for designing an enclosure, I will briefly explain how a standing wave works. When a subwoofer plays a note, it creates what is known as a standing wave. This wave oscillates up and down along a straight line until it bounces off another surface, creating a freestanding wave. As a sound wave travels farther away from its source, it will lose form and start to dissipate. So a freestanding wave that moves freely around a box as it dissipates is what the user hears as distortion. In ported enclosure, these notes have more space to travel, making it harder to have a noticeable effect using this type of enclosure design. Since space in a sealed enclosure is a lot more confined, the effects of this design are a lot more noticeable. Since the standing wave has nowhere else to travel, it is forced into the crevices created by the peaks and valleys of our wave design. As the note rapidly moves across the surface, much like a ricocheting bullet, it loses energy with every bounce. By doing it this way, the freestanding waves are quickly dissipated, leaving only the true, undistorted sound for the user to hear. To start this build, we first have to sketch out our design and rough cut the center section. Since this design features alternating waves, we must create two templates in order to create our number 1 sections and our number 2 sections. After the rough cut, we can either freehand the finished cut, or we can use a top bearing router bit and our jigs for greater accuracy. Now our templates are ready to be used as stencils in order to transfer our design onto the remaining sections. Once we are finished with that, it is now time to rough cut your remaining sections. For the sake of our time and sanity, we are using 1-inch MDF wood instead of the normal 3/4 inch. This reduces the total number of sections needed by 25%. Once the rough cutting is finished, we can speed the finishing cuts up by taping our template to the middle of 2 rough cut sections and then using it as a guide with the top bearing router bit. This way, once you finish one piece, you can simply flip it over and do one more. With all our sections cut out, the final step here is to chamfer our inside edges. A 22-degree chamfer is all that is needed to take the sharp corners off the inside of the enclosure, leaving no flat surfaces for our sound waves to bounce off of. With all our pieces cut and routed, it is time for us to assemble our enclosure. Starting with our 2 templates, we need to layer the pieces together using wood glue and crown finishing nails. First, apply a thick layer of wood glue to the surface of a piece. Next, make sure your pieces are square and nail them together using 4 or 5 crown finishing nails. Make sure you're mindful of any nails that are still sticking out. Sometimes you have to use a grinder to grind back any nails that aren't flush. With our templates fixed together, we can now start alternating our number 1 pieces and our number 2 pieces as we add them to the overall structure. After a layer has been glued and nailed, we need to run the outside edge of that layer through our top bearing router bit. This way, as we build out the enclosure, all our pieces will be flush with the inner template. Once you have stacked all your pieces together and your box is at its desired volume, it is now time to compress our enclosure as the wood glue cures. By doing it this way, the glue has time to set while under pressure. This helps press the glue deeper into each layer of wood so that once pressure is released, the bonds between the pieces of wood are actually stronger than the wood itself. This means that the enclosure is more likely to break down the center of a piece of wood rather than at the joint between 2 pieces. In layman terms, this means our enclosure is really structurally solid. With the glue cured, it is now time to sand the outside of our box. We use a pneumatic sander and some fine grit sandpaper. The sanding process removes any excess glue or sharp edges causing the outer surface to not be flush. This process also provides us with a smooth exterior that will help prevent tearing of our vinyl when we later wrap the enclosure. After making several passes with increasingly finer sandpaper, the enclosure is now ready for a hole to mount our subwoofer. We start by lining our pre-made cutout template and trace it onto the enclosure. Then we use our skill saw to make a rough cut of the hole. Make sure that when you are cutting, you stay on the inside of your line. We are going to tape our cutout template back over the hole and use it with the bottom bearing bit on our router. This ensures a more accurate finished cut. With our mounting hole cut, we need to now test fit the enclosure so that we can measure how tall the feet need to be on our end caps. Not all cars are the same, so these end caps will have to be custom in order to mount the enclosure in the preferred location. For our car, this enclosure is being mounted on the top of an amplifier. We need to have legs that allow for ample airflow underneath the enclosure in order for the amp to stay cool. We start by cutting wood to the same width as our enclosure pieces, while leaving extra room for us to draw our legs. With the help of our angle jigs, we can trace out the shape of our legs. After cutting both ends to shape, we can cap them on the same way as the main sections by using wood glue and finishing nails. One last ride on the shop press as the glue cures is all that is needed to make our box functional. More sanding and flush cutting may be required to make the enclosure pretty, but at this point your enclosure is ready for music. For an expensive enclosure like this, we are going to give it a nice outer finish. After more sanding and using a roundover bit on our outer edges, we are ready to get wrapped in vinyl. This process can be long and tedious and is often compared to as reskinning a bear. For the inside of our legs, where the vinyl is hardest to wrap, we've gone ahead and used conventional box carpet, so this way it's still functional and it saves us some time. Once this is finished, we can attach beauty panels that we made earlier. The enclosure is now ready for a subwoofer. Using a drill, we cut a small hole the width of our speaker wire into the back of our enclosure. Then we run our speaker wire, making sure to knot it on the inside of the enclosure. This prevents someone from pulling the wire back out of its hole. Next, we strip the ends of our wire and crimp on some connectors. Then we plug in our subwoofer and lower it into the cutout hole. Next, we pre-drill out our screw holes to prevent any cracking, which gives us a strong mount. We use panhead screws to secure the subwoofer into place. Never, and I repeat never, use a drywall screw to mount a speaker. Any credible shop knows the difference, and it speaks volumes for the kind of work you do. With that being said, our build is finally finished. A quick tune on the amp and our customer is ready for a new stacked enclosure. If you like what you've just seen, please subscribe for more content. This has been a production of Area 41 in Kennesaw, Georgia.